All right, yeah, welcome back. My name is Victor Didomo here, and in our class today, we are going to be looking at how to derive the quadratic formula. We've been doing some algebraic, activity. We've been looking at functions, polynomials, and I think we have been able to solve some problems around the division of polynomials by a polynomial of a lower degree. And we also looked at how to, factorize a cubic equation. We've looked at these classes, and right now we're moving towards solving some quadratic expressions, looking at some things around quadratic expressions. In the last class, we were looking at what we call understanding perfect squares, because we need that understanding because it's going to help us in solving quadratic equation using completing the square method. So, without taking our time, have you been able to take a look at how what you call the quadratic formula is derived? How to derive that quadratic formula. That is exactly what we are going to do now. We are going to derive the quadratic formula, and thereafter we'll see how we can use it to solve quadratic problems. Okay, this is how it goes. It's going to take us like 6 or 7 steps. I'm not going to write those steps, so we'll take it. So if you have your note there, while I mention those steps, you take them down, and then I will do the necessary thing I need to do to show you how the thing goes. Look at this. I have this. Ax squared plus bx plus c equals to 0. And within the procedures we follow in deriving the quadratic formula, the first step is divide. You can take notes. Divide the expression. Hmm? Divide the expression by the coefficient of the second degree term. The second degree term here is this has degree 2. Okay, so the coefficient is a. So we use this coefficient to divide the entire expression. So we have it. When you use a to divide everything here, you are going to have left x squared plus b over a x, then plus c over a equals to 0. That's what you have left, because a will cancel a here. Number 2, take the constant to the right hand side. Take the constant to the right hand side. So what I do is I write x squared plus b over ax, not now equals to, then this is going over here to be minus c over a. Okay, all right. The next is, this is where the issue that has to do with the last class comes in. That last class, I took my time to explain the understanding of the concept of perfect squares, because what we are going to do here now is to make this expression to be a perfect square. So I explained it clearly. I used about 2 examples or so in the last class. So please check that class that says understanding perfect squares. Get? So it will help you to embrace this I'm going to do now, because in 3 steps I'm going to make this to be a perfect square. The first step is, in that class, as I said, take the coefficient of x. The coefficient of x here, coefficient of x is b over a. Half of it is 1 over 2 times b over a, and that is going to give b over 2a. Then the next is square it. Then you have b over 2a, then you square it. Then this is what we are going to add to both sides of this expression. Once you add it to this side, this automatically becomes a perfect square. See how good it is? Yeah. All right, let's go. We have x squared plus b over a x, then plus b over 2a squared. Then this is now a perfect square. I can now write it as a product of 2 factors that are the same. So let me take this first. Let me take this first, because this is positive before putting this negative value. So in detail, or in in the real value of it, this will be b squared over, this will be 4, because this 2 squared is 4, and this will be a squared. So minus, now put minus c over a. Okay, I'm sure that is clear. Very, very clear. I hope there's no problem. Let's move on. Now, I am making this now. How many steps have I taken? I'm sure you're taking note of the steps. The next step now is make this left-hand side to be a perfect square. And it's so simple. It's a perfect square already. This left-hand side is this is the perfect square expression. So I won't express it in as a product of two factors now. And how do I go about it? Should I start factorizing this? That's why I gave that class understanding perfect squares. So I'm just going to pick here and here x and whatever I have inside this bracket. That's why obviously you leave it like this. Assuming in the next class I'm going to be showing us how to solve quadratic equation using completing the square method, and it's just the same thing we are doing here. So you realize that whatever I have here, I'll put it here, b over 2a, and then square it. It's a product of two squares. This as a product of two squares equals to, we now have I'm going to solve this now. This is, I'll find the LCM of this and this, and that's 4a squared. I hope we follow. It's 4a squared. So 4a squared divided 4a squared is 1. 1 times this is b squared minus a divided 4a squared is 4a. A divided 4a squared is 4a. So we will now times it with c, and we have 4ac. Okay, let me come over here. Okay, so what do we have? I don't know whether this place can be. Let me do it here so that I need you to capture what I am doing clear. Or let me attach it here. I have here x minus, rather plus b over 2a, okay, squared equals to b squared minus 4ac all over what? 4a squared. So the next step is make both sides to be, no, the next step is take the square root of, we have made this side to be a perfect square. So the next step is take the square root of both sides. Okay, so you take the square, that square root will now clear this. Do we get? It will now clear this. So what do we have? We will now have x plus b over 2a. Okay, so that, oh yeah, so we have x plus b over 2a equals to, when you take the square root of this, we will have root b squared minus 4ac all over. You can have the square root of 4 and you can have the square root of a. So we'll write it as square root of 4 is 2 and square root of a squared. The square root will clear the square. This square here. So we will have a left. It's just like you are having something like this. Do you get? So this will take care of this. So you now have this. So what do I have left? I will have x. Let this come over here. I will now have, it will become minus b over 2a. I am either adding or subtracting to root b squared minus 4ac all over 2a. So you see that the denominators here are the same. So by LCM, you can have x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. This is what we call the quadratic formula. Okay, and this is how to derive it. When we derive this, we also use it in solving quadratic problems. We are going to look at that in the next class. I don't want this to be too long, so that's why I will not give that example right away. Okay, so but one thing you need extra to know is just like a bonus I want to give you now. You see, This procedure we use in deriving this is the same procedure you use in solving quadratic equations by completing the square method. It's the same procedure. So I'm going to do that example and also do the example of using this formula to solve quadratic equation. I hope you'll be there. Okay. Now, you subscribe to the channel. You know when you do that, you know exactly what you're doing? You're just telling us that what you guys are doing is good. It's a way of encouragement and it's a way of saying, oh, thank you for helping me to understand this. Okay. And then you click on this notification button so that when we make the next class and upload it, you get notified. And then you like what you are doing as well. Okay. I know you're going to do that. And I say thank you for doing that.